Welcome to GEOG485 585L, Internet Mapping, Module 5.1, Platforms and GeoServer Introduction. In this week's lecture, we will provide a review of the services-oriented architecture model that we have been working with all semester, with a focus now on the relationship between the server-side technologies we will be discussing here as they relate to the client-side capabilities that you have been focusing on for the past number of weeks. As we lead into our discussion of the server capabilities that we will be working with, we will discuss some general characteristics of a server platform. We will discuss a number of online mapping server applications, including commercial off-the-shelf applications and open source tools. We will then drill down into a more detailed discussion of GeoServer, the open source platform that we are using for this class, as a publication platform for the OGC services that you will be developing as a part of the class for sharing data with others. With this week's discussion focusing on beginning to work with GeoServer and a demonstration of the user interface and the various components of the interface. As was introduced in the earlier part of the course, we are working within the context of a broader concept of a services-oriented architecture for geospatial data and information. With that services-oriented architecture, or SOA, consisting of at least 3 tiers. The first being an underlying data tier that is optimized for the management of data in a variety of formats. Additional processing tiers in the center of the architecture, where derived products may be generated. And finally, user and client tier, where applications make use of the published services to access and modify the data and information published from the data tier. In our work with Google Maps API and OpenLayers and the Open Geospatial Consortium standard services, we have really been focusing in the upper 2/3 of this services-oriented architecture. In essentially the client interfaces and in the interoperability standards that enable the delivery of data and information into those client interfaces. This week, we begin our discussion of how to implement a server platform to actually provide those services, to allow the publication and sharing of geospatial data and information with other systems, other client applications, using, in particular, the Open Geospatial Consortium Web Map, Web Feature, and Web Coverage services. As we move forward, it is useful also to remember that the standards that we are publishing make use of web standards as they are accessed through the various client interfaces that we have discussed thus far. And as a matter of fact, the GeoServer platform itself is actually published through a web application that is accessible through the browser and that is based upon the same web technologies of HTML, cascading style sheets, JavaScript, and XML that the web applications that you have been developing based on Google Maps and OpenLayers. And as a result, you can transfer some of your understanding of how your web mapping applications operate to an understanding of how the user interfaces that are published by GeoServer are made available through the web browser that is the core of the model with which you interact. as an aside, though it's not something we will work on here, GeoServer also supports a representation state transformation access model as well. So if you move forward and you continue wanting to work with GeoServer, you can keep in mind that you also have the option of developing interaction models that use the REST model as well, in addition to the OGC standards that we will be focusing on here. As we start talking about servers and platforms, we need to think about the raw materials from which a server is built. And at the highest level, a server and associated geospatial data services platform is built from three high-level components. The first is the operating system. This is actually the underlying software environment that all applications on a particular computer system operate within. So the operating systems that you may be most familiar with include the Windows operating system in its various forms, the Macintosh operating system, or the Linux operating system in all of its various flavors as well. The operating system provides the core set of capabilities upon which all other applications are built, and provide also the user interfaces in instances when users are interacting directly with the computer. In the context of our work here, the operating system is the platform for a set of web applications and services. On top of the operating system, as a foundation for those web applications, is typically a web server of some type, where a web server is simply a particular piece of software that is designed to listen for incoming requests over the internet using the HTTP protocol, with that software designed to then take those incoming requests, interpret them, potentially execute some additional code, and return data or other information in response to those HTTP requests that are sent to the server. Examples of web servers that you may encounter on different platforms include the Apache web server, which is an open source platform very broadly used across the internet, and the Microsoft Internet Information Server, or IIS, which is a platform that is commonly used on Windows servers specifically, as it is limited to that particular platform, as it is a Microsoft product specifically designed to run under Windows. There are certainly many other web server applications out there, but Apache and IIS are two of the most common that you will encounter. Then sitting behind that web server, you will then typically find the mapping server, where that mapping server provides the specific geospatial data access, processing, and visualization capabilities that comprise the mapping capabilities that you are publishing over the internet. So you could think of this as a specific set of capabilities that are exposed to the internet by the web server, with both the web server and the mapping server running on top of or within a particular operating system. And while there are a variety of mapping platforms and mapping servers available, there are a common set of capabilities in terms of frequent support for the Open Geospatial Consortium service standards that we have been discussing in this class, but also often supporting additional proprietary or non-standard service interfaces as well. And while these are capabilities that you might encounter in a number of different mapping server applications, our focus here is going to be on one particular mapping server, GeoServer, and one particular set of service interfaces, the Open Geospatial Consortium Web Map, Web Feature, and Web Coverage services. There are a number of mapping server applications, as I've already mentioned. And here are some examples of some applications if you wanted to look for additional information about those platforms. And this is only a sample. One commonly used commercial off-the-shelf application includes the ArcGIS server platform itself, which in addition to supporting ArcGIS specific service interfaces, also may be enabled to support the OGC services that we are focusing on here. CubeWorks Studio is another COTS application that provides OGC services in particular, and has been a long-standing provider and vendor of server platforms for the OGC services. Erdos Apollo is a third commercial off-the-shelf application platform that can also support the open standard services in addition to their own service interfaces for other applications. If you are interested in open source mapping platforms, while there are a number of platforms out there, the two most broadly used platforms include MapServer, that started as Minnesota MapServer when it was originally developed at the University of Minnesota, but now is pretty much just generically referred to as MapServer, and GeoServer, the system that we will be working with in this class and that we have installed on our class server. So what is GeoServer? GeoServer is an open source, open standards platform that supports a number of geospatial web services. It is published and shared using the GNU General Public License, which, as we discussed in our very first class session, as we were talking about open source software, means that it has embodied within it a number of freedoms associated with access to source code, rights to modify that source code, and the right to share those modifications without limitation. As a result of these freedoms that are associated with open source software, GeoServer, like many other open source applications, is available for free, though there are some business models that have been built around GeoServer and other open source platforms in terms of providing commercial support or hosting for those applications. GeoServer has been designed from the ground up as a reference implementation of a number of Open Geospatial Consortium service standards, including Web Map services, Web Feature services, and Web Coverage services. It also implements the OGC Styled Layer Descriptor styling standard for defining styles that can be applied to the service layers that are published as a part of GeoServer. GeoServer is written as a Java web application, and it is commonly hosted on the Jetty web server and also within the Java Servlet engine environment. And since it is based in Java, an appropriate version of Java must be installed as a part of the operating system and software environment on the server upon which GeoServer is going to run. So when you're working with GeoServer, the first step is to actually install and configure GeoServer to run on a particular computer system. To accomplish that, a number of operating system independent binaries have been developed where they can just be run on the system that they've been installed to start the server and initiate the server listening for incoming requests. So these OS independent binaries include, in this case, the Jetty web server or HTTP server, where these binaries are available for the Windows, Mac, and Linux operating systems, where there are also a set of operating system specific configuration instructions for each of those operating systems to fully integrate these independent binaries into the operating environment of each of those systems. If you already have an existing Java web servlet application environment, you can also use the distribution as a web archive of the GeoServer code that allow you to install it within that existing Java environment on an existing system. And finally, there are operating system specific installers that can also be used that typically include an integrated web server and the necessary mapping software components, where these operating specific installers are also available for Macintosh and Windows servers. As we think about the interaction between clients out on the internet and the GeoServer application environment, you can think of it as a sequence of exchanges that pass through components of the software and network system. This diagram illustrates that process, where you can envision the incoming arrow with a 1 next to it coming from the internet that represents a particular mapping request or data request. That request first is acquired by the web server, which then passes it through the Java servlet engine within which GeoServer is running. And that servlet engine then routes the request to GeoServer itself. When GeoServer receives that request, it then translates it into a needed data access request to wherever the data are that are being used by GeoServer. Those data may exist in a local file system, in a set of directories or folders and files. They may reside in one or more geospatial-enabled databases, represented by the GeoDB cylinders in the diagram. Or they may actually be externally hosted web feature or web map services, where the request that is received by GeoServer may actually be processed and forwarded to an external service for completion in terms of retrieving from those external services either a map image or a data object, which GeoServer then further processes and returns to the requesting client back through the Java servlet engine to the web server, with the web server ultimately returning it over the internet back to the requesting system, represented by the arrow with the 3 next to it in the diagram. This process is repeated over and over again for every request that is submitted to the system and every response that is returned. So after the initial setup and installation, you can do further configuration of the server through the web interface, where that is actually the first test to see if you have successfully performed the initial installation, is and attempt to connect to the web interface and the additional configuration tools. In order to modify the configuration of the system, you must log into the web interface as an administrative user. And in a default installation of GeoServer, the default username and password for a new installation of GeoServer are admin with a password of GeoServer. A key thing to keep in mind is that if you're deploying your own GeoServer instance, you must change the administrative username and password. Otherwise, your system will be liable for getting hacked by external users who know the existing default username and password and can use it to try to access your server and modify its configuration. After logging into the server, you can then view and modify the configuration of the server and its associated services, where a number of the configuration elements then are rolled into the capabilities of the Open Geospatial Consortium services as they are advertised by the server. Once you have logged in as an administrative user to GeoServer, the left side of the screen provides a number of options and command groupings to be able to drill down into the wide range of configuration options that are available for GeoServer. The first set of options that you want to look at are the server configuration options, highlighted in the screenshot here from the menu. Within that, you have a number of areas within the configuration that you can access. First off, there is the server status area, where you can see some summary information about the current server instance, and within that area also have the opportunity to reset some capabilities within the server and modify the current running state. You can also provide contact information for the server as a whole. This is information that is then used as a part of the Get Capabilities content that is advertised for any of the OGC services that are broadcast by the server. You also have access to a set of global settings, again applying to the server as a whole, with these global settings largely focusing on options related to logging, the capturing of information about the ongoing operation of the server, which if the server is ever operating in a manner that you don't expect or you want to examine how it's operating, you can look at the log files to see what requests are being submitted and what the responses to those requests are, and depending upon the degree of detail that you have selected for your logging, also any errors or warnings that are generated in response to those incoming requests. You also have, within the server configuration areas, a set of options for the Java Advanced Imagery Engine that is used in generating a number of the visual products that are produced by GeoServer, and then a web link that will take you to the GeoServer site itself where you can get additional information about GeoServer. As we move down to the services block of configuration options, the focus here is upon the OGC web map, web feature, and web coverage services, where there are some options that are common to all of these services in that they show up under each of the sets of options for the web map, web feature, and web coverage services, in addition to some service-specific options that we will talk about in just a moment. So the options that are common for all three of the OGC services that are published by the GeoServer platform include the ability to enable or disable the specific service, and also to determine whether or not each of those services should essentially run with strict compliance to the OGC conformance standards, or whether it should operate with some slightly relaxed criteria. This provides GeoServer to do conformance testing against the test suite that has been developed by the Open Geospatial Consortium, but then with the strict site compliance disabled, it allows for a slightly higher level of non-compliance when it comes to incoming requests to the service or services and being able to respond to those requests, though they aren't 100% valid in terms of the OGC standard and version that they are theoretically using. There is also service-specific information about the maintainer of the service and links for online resources for the service where you can customize those at the level of the service. Also, a title and abstract that you can define at the service level. Any fees or access constraints that are also available at the level of a specific service. And then any keywords that are associated with the service as a whole. Keeping in mind that these keywords are separate from any keywords that may be assigned to the individual layers that also comprise a service. When we get down to the actual services themselves and the options that are specific to those services, there are additional options that are not common across all three. In particular, when defining the characteristics of the web feature service that is published by GeoServer, you can define the maximum number of features, a limitation that we encountered for the first time in our demonstration of client interactions with web feature services and QGIS in our previous lab, the type of web feature service that should be hosted. As you might recall from our discussions of the different implementation levels for web feature services, whether they're basic services or whether they also support the transactional model and are a complete implementation of the WFS standard, and also the styles of representation for geography markup language or GML data products that are delivered by the WFS published by GeoServer. For the web map services, you also have a specific set of options that you can provide that are limited only to the web map services, with one important one being the ability to define a subset of spatial reference systems that will be advertised as a part of the web map service. The reason that this is important is that some client applications have a difficult time handling large numbers of advertised spatial reference systems. And GeoServer is pre-configured with over 4,000 spatial reference systems and advertises a large subset of those as available spatial reference systems as a part of the WMS Get Capabilities request. It is a good idea when configuring GeoServer to define an SRS subset for that particular service so that you can shorten the Get Capabilities XML response to include only the SRSs that you really are interested in supporting explicitly, as opposed to just having the default really long list of SRSs, spatial reference systems, that are automatically advertised by GeoServer. You can also define the interpolation method used in generating map images from the source data, set some limits on the computational resources that should be consumed in satisfying incoming requests, options related to the generation of KML as one of the requested file formats from the Web Map service, the ability to integrate watermarks into generated web map images so that you can actually essentially brand or visually tag map images that are generated by this service as being related to this particular server instance using a watermark in the image. And then also some options that relate to compression and other capabilities of PNG, JPEG, and SVG formats that are published by GeoServer. The WCS implementation within GeoServer pretty much just consists of the base set of capabilities that we discussed on the previous slide and has no additional configuration options within the that are specific to WCS. Finally, the current release of GeoServer also includes a web link with information about the currently developmental tile cache technology that is available within GeoServer that provides initial support for tiled variation of some of the OGC services and potential client consumers of those tiled services. Of key importance as you are integrating new data into a particular GeoServer instance to be published using the OGC services are the options for viewing the configuration of the various data components within GeoServer. And while we will discuss the required workflow for bringing data into GeoServer in a moment, we'll first look at what the various data component configuration options are within the menu. With the first being a link to the Workspaces configuration area, where the workspace model allows you to define containers for what GeoServer often describes as related data products, where that relationship may be specific to your particular use of the server, but the GeoServer platform suggests that these workspaces relate to similar types of data. In the context of this class, we will be using workspaces as essentially your individual area to be working on lab and homework assignment projects. So each student in the class will develop their own workspace and associated stores and layers. Stores are essentially configurations for specific data sources, where those data sources will often be data sets that are stored on the local file system, but also may reference external web services or even geodatabases, with the store configuration representing all of the information needed to interact with the source data. So to be able to find it on the file system, or to be able to connect to the external database, or to be able to connect over the web to an external web service. These are all examples of the types of information that would go into the configuration of a specific data store that is then stored within GeoServer and available for then the creation of data layers. The layer option then allows you to have access to a listing of the defined layers that are published by the server, with each layer being based upon the data that are provided by a store, but with each layer also having layer-specific settings that may vary from layer to layer, even if they are based upon the same source data defined by a store, where some of that additional information within a layer may include a bounding box and styling information and attribution information for that particular layer as it is advertised as a part of a service. There are also layer groups that can work across different workspaces and stores, where essentially you can bring individual layers together into a particular collection that might relate to a particular project or application. And the layer groups option within the configuration menu provides access to the list of current layer groups and options for being able to update or modify or create new groups of layers. The styles option provides a listing of styles that have been defined within the server and provides access to those styles for modification or creation or deletion. And we will be working with styles starting next week as we continue our discussion of how to customize the presentation of layers that are added to GeoServer. Finally, at the bottom of the GeoServer option list, there's a layer preview link. The layer preview interface allows you to actually see a listing of the available layers with a number of options for being able to view those layers either in an interactive mapper within GeoServer or also using the variety of service requests that are available for each of those layers. So the layer preview provides a powerful method for actually testing the data that you have brought in into a particular layer and being able to interact with the layers within the GeoServer environment before you even try to use any of the published layers outside of GeoServer. Given the different components of the data creation process, it's useful here to talk about essentially the general process for integrating new data sets into GeoServer, with that general process illustrated here in this diagram, where the first step is to actually add the data object to the GeoData or the GeoServer repository, essentially the directory where GeoServer will be looking for those data. Of course, this would only be the case if you are using a file-based data source. If you are using a database or an online web map or web feature service, you would skip this step and go directly to the next one, where you determine whether or not a workspace exists for your current collection of data that you want to be working with. If a workspace does not exist, you need to first create a workspace by going to the Workspace area within the configuration menu and choosing to create a new workspace. If a workspace already exists, you can then go directly to the point where you would create a new data store by clicking on the Stores option in the configuration menu to create a new data store that points at the data object or service that you want to add to GeoServer. Once the store has been created, you can then create one or more layers based upon the data that are provided by that store, keeping in mind that you can have multiple layers defined based upon the data from a single store, where you can then modify the characteristics of that individual layer in terms of potentially, say, the bounding box that you want that layer to focus on, attribution, different default styles for those layers. You can set all of those at the layer level, so you can actually, for example, have, say, a road data set that you've developed 4 different styles for, and you could actually create 4 layers based upon that single data store representing that road network, and set the default style for each of those layers to a different style as it would be presented in a user in response to a user request. You can also link multiple styles to a particular single layer and provide them as options, but that's one scenario where you might want to have multiple layers pointing at the same data, each styled a little differently. Once you've created a layer, you can then test that layer in the preview tool to make sure that it is behaving the way you expect it to and delivering the information you want. Once you've done that and it meets your satisfaction, you are then finished with the integration of that particular data set into the set of services that are published by GeoNetwork. You can then start the process again with a new data set. There are also a set of security settings that we really won't be working with here, but that you should at least be aware of if you ultimately decide that you would like to experiment more with GeoNetwork and you're working on setting up an instance of it on your own system somewhere. And these relate to security settings. And in particular, settings that provide you the ability to manage the users that can log into your GeoServer and the roles that those users can be assigned to, as you then can use the roles to define the access privileges and associations for data security, determining who can read or have read-write access to the data products within the server, how you can also assign access to or use of specific services. So you can define at the user role level who has access to web map, web feature, or web coverage services, and even their related request types. So you may allow, say, get capabilities requests for all user types, user roles, but you may only allow get coverage requests for users that have been assigned specific roles, where there would be a required authentication for a user to be able to successfully execute a get coverage request if their user account on GeoServer has been assigned to a role that has access to that get coverage request. There is also catalog security, where you can determine how layer information is exposed to different user roles, where layers may be entirely hidden, or they may be exposed in terms of listing that they exposing that they exist, though the users may not have access to them if they were to request data for those layers. This is where you can use catalog security to modify the settings about how information about the catalog of layers within the service are made available to external users. With this background, let's now go through a quick demonstration of the GeoServer interface so that you can have a general idea of what it looks like and what the different options are, so that as you start experimenting with the class server, you're able to make more productive use of the capabilities of GeoServer. This is what the default GeoServer homepage looks like before you log in. And to be able to actually view the administrative menu that we've been discussing, you need to first log in as an administrator or other user of the system. So in this case, I'm going to log in, providing my username and password. And as I am now logged in, you can see the menuing system on the left-hand side and the general content and information area on the right. And as I click on each of the options, you can see the content of that particular area of the interface. So here is the server status display for the GeoServer instance, where you can see information about the current running status of the system, and you can also see some options in terms of being able to reload the configuration or free locks on content within the system to free up memory that is currently in use, or also modify memory that is in use by the JAI system. But this is primarily an environment for viewing the current status of the system, where you can see the current information about it. If we click on contact information, you can see that I have already customized the contact information with my own contact information, where this is the information that will be provided as a part of the Get Capabilities request for the OGC services that are published by the GeoServer. Here are our global settings, where we can modify the types of messages and exception reporting that are provided, information about the number of decimal points used in the system and the default character set, and then additional logging information, including where the log file should be stored. And then here is a set of options relating to the Java Advanced Imaging capability within the system in terms of the memory capacity and threshold, and other options for tuning up the image generation and management capabilities of the system. If I click on the About GeoServer link, that takes you to a general page here that then links out to the documentation for this particular version, a wiki that is related to GeoServer, where you can find lots of additional documentation about GeoServer and its ongoing development, and then a bug tracker where you can actually submit bugs or identify bugs that have been provided to the GeoServer development team and see what the status of those various bugs are. If we move down to the services area, if we look at the web coverage services, we can see that this includes pretty much just the common options that we discussed a few minutes ago, where we can enable the WCS service and enable whether or not it will be in strict compliance for conformance, or whether it will use slightly looser criteria, information about the online resource and maintainer for the service, and then a title, abstract, and associated fees and access constraints and keywords for this particular web coverage service. For the web map service, we have the same base information at the top. And here you can see that I have limited the SRS list using the limited SRS list option for WMS to pretty much the WGS84 geographic coordinate system, the UTM NAD23 and NAD27 UTM Zone 13, the 900913 spatial reference system that can be used to integrate data from this service into, say, open layer services that are also using some of the commercial or proprietary base maps, as you learned as we went through our open layers examples a few weeks ago. And then a variety of state plane coordinate reference systems for New Mexico. So if you are bringing those data in, you can also advertise the availability of services using those state plane spatial reference systems, in addition to the UTM geographic and 900913 spatial reference systems. You can also see that I've chosen nearest neighbor as the default interpolation method for the generation of map images from the web map service. A number of options. In this case, I have just kept the default values for generation of KML from this WMS. And then also continue to accept the default values in terms of resource consumption. I do not have watermarks enabled, and I haven't modified the PNG, JPEG, or SVG options. I have just essentially, in this case, gone with the default values for each of those image types for this web map service. For the web feature service, again, I can enable or disable the entire service and enable or disable the strict compliance settings. Otherwise, it has all of the base settings, and then also the option to limit the number of features that will be returned by the server. In this case, I have kept it at the default value of 1 million, but depending on the types of features that you have as a part of the server, or the types of server resources you have access to, you may want to reduce this number to something different or change it to something different. You can also see, in this case, we have enabled the complete level of WFS service, supporting all of the WFS options and optional and required capabilities. And we have chosen, in this case, the default values for both GML2 and GML3 in terms of how they present the SRS content within the information embedded in those GML documents. So this is an option that you have available to you that is supported by those different versions of geography markup language. In this case, we are leaving those as the default value. And again, there's an option for additional conformance with the standard in terms of pointing to the official WFS schema location as opposed to one that is locally accessed as a part of the GeoServer instance. As we look in the data area, we can first look at the workspaces to see that the default release of GeoServer includes 3 workspaces. You will be adding your own workspaces as a part of the exercises for your homework and lab exercises. But it's through here that you can access the information about individual workspaces or add new workspaces, where I can click on an existing workspace name and see the information about that particular workspace. Or I can choose to add a new workspace just by clicking on the link. And here I'll just name this workspace Carl. And I will give it a URI, which does not have to be a web address that is accessible over the internet, but it can be if you'd like. The key requirement is that it does have to be unique within GeoServer. So in this case, I'm going to name my namespace URI as geog485.unm.edu/Carl and click on Submit. So now we have an additional workspace name, and we can see the information about that workspace that I've created here. This is a process that you will need to go through as the first step in adding new data for your assignments into the GeoServer instance. You can then look at the stores to see the existing data stores that have been created within the GeoServer system, where the listing of each store includes the workspace that it is a part of, and then also the name of the specific store, and also, again, a link for creating a new store. So if you want to view the information about a particular store, you can click on the store name. And this is where you can see that this store is a part of the GN workspace. It's been given a name and a description where that store is enabled. And then the connection parameters that actually define how to connect to that particular store. So this is the information, in this case, since this is a file-based store, this is the information that is needed for GeoServer to be able to find the data set for this within the local file system. An option for creating a spatial index for the data, which will help the performance of the system. The character set for that data set. And then whether or not there should be an additional memory mapped buffer associated with this particular data source. If you don't understand what those various settings mean, you can certainly go to the documentation, or at this point, accept the default values until you want to modify them to something that is specific to your particular project or data. Once you have either updated or created a data store, you can hit the Save button. And that's the same process for any of these data sets, where until you hit the Save button, any changes you make will not be written into the system. In this case, since we didn't make any changes and we don't want to save any changes, I can click on Cancel. And that will take me back to my stores list. And as you might expect, I can click on the Add New Store option at the top of the screen here to add a new data source to the system, where the available data sources and types are listed here in the New Data Source screen, where you can then click on the particular data source type to bring up the dialog associated with that particular data source. So for example, if I wanted to access a GeoTIFF file, I could just click on the GeoTIFF link here. That brings up the Add Raster Data Source form in this case, where I can then give the data source a name, a description, and then a link to the data file that I'm wanting to add. Where again, if it is a data file that is on the local file system, I would specify it using the example format that they have here, where it would start with file : and then the path and file name for the specific data set that you're adding. In this case, since I haven't modified any of this and I don't want to save this, I can just hit cancel. So assuming that the data store that I want to work with has been created, I can then click on Layers, where Layers provide access to, as we've already discussed, all of the layers that have been created as a part of the GeoServer instance. Where in this case, similar to what we've seen for the previous Workspaces and Stores examples, a listing of the available layers, where each layer includes the workspace that that layer is a part of, the store that provides the data for that layer, and then the layer itself, where the information about that layer can be accessed by clicking on the layer name within the list. So if I click on this world layer name, we can see the information about this particular layer in the interface, where we can see the layer name is world and has been given a title of Blue Marble World Image. You can add an abstract that is specific to that data set, as you can provide keywords that are specific to that particular layer. And if you have additional metadata, you can add a link to those metadata as a part of the configuration for the layer itself. You can define the coordinate reference system for the layer, both in terms of a native spatial reference system, and then also the spatial reference system that will be declared as being the advertised spatial reference system. In most cases, it's good to have them as the same, in that you are declaring the same spatial reference system as the data are in, but you can, with this option for SRS handling, allow GeoServer to do automatic reprojection into another spatial reference system. So if, for example, your data are in EPSG4326, but you want to declare that the data are in EPSG 26913, UTM NAD83 Zone 13 North, you could set your declared SRS to 26913 and make sure that the SRS handling is set to reproject native to declared, meaning that GeoServer will be doing automatic reprojection to provide those data that are natively in 4326 to automatically do the reprojection into the declared spatial reference system of 26913. In this case, we're going to leave these the same and leave it at that. You also have the option of setting the native bounding box, where the bounding box in this case is in the native coordinate reference system units. So in the case of our data being in 4326, we would enter the native bounding box in geographic coordinates. If you want to have the bounding box read out of the data, you can click on this button to compute from data, and you can see it is now updated the native bounding box to essentially this global bounding box that corresponds to this particular data set. And then you can also in an instance where your native coordinate reference system isn't in latitude, longitude coordinates, you can actually then have it calculate a latitude, longitude bounding box as well, because as you might recall from looking at the WMS Get Capabilities request, you are often presented with two pieces of bounding box information for each layer. One that is in the native coordinate reference system, and the other being a latitude-longitude bounding box. This is where you can provide the information for both of those representations, or have it compute those from the information either in the data, included in terms of the native bounding box, or from the native bounding box in terms of the latitude-longitude bounding box. In addition to data information about the layer, you also have publishing information about the layer that you can set, where you can modify the request spatial reference systems that are supported by this particular layer. This would be in addition to those that are advertised by the service as a whole, as I customized the service to provide that subset of spatial reference systems. So if the current layer is in a coordinate reference system that might be different from that default set, I could actually include that spatial reference system here that would be provided in addition to the service SRS that I defined for my web map service up above, as an additional SRS that is available for this layer only. You can see here that I can actually apply a different interpolation method to this particular layer, which is separate from the default interpolation method used by the service as a whole. In this case, we can see that this layer is already enabled for both bilinear and bicubic interpolation as options as a part of the service. Here we can modify the available formats and define what the native format of the data are, in addition to the available formats that are advertised for this particular data set. Again, remembering that you can modify the selected formats available for a particular data set if you'd like, or a particular layer if you would like. You can modify the name of the layer as it is presented through the service. You can do some specific web settings in terms of whether or not the outputs of this service for this layer should be cached or not. This can be useful if you have a data set that is being frequently updated, where you might want to modify the amount of time that a client might cache a previously requested map image. So if you're updating your data every second, you might want to modify your cache time to 1 second, meaning that as long as the cache is younger than that, it will be used. Otherwise, a new map request would be submitted. We then have a set of WMS settings, including the default style that is provided, where you have a listing of all of the styles that have been defined within GeoServer. In this case, we're setting the default style, so if a style is not provided as a part of the WMS request, the default style will be used. And we can then define essentially what other styles might be available in addition to the default style. So these would be advertised as specific styles that are available for that layer that could then be used as a part of the style request within that WMS get map request that you have become so familiar with over the course of the semester. You can do that by just choosing a style from the list here. So let's, for example, choose DEM. Say we know that this is an elevation model. we can choose DEM as a selected style, so that will be advertised for this layer as an additional style that can be requested by name with that styles parameter as a part of the WMS request. In this case, since this is not a DEM, I'm going to leave it at just the default raster style. We can also then have a custom attribution for this particular layer that would be different from the attribution for the higher level service. So this is where you can have information that is specific just to this particular layer, that it does not propagate across the rest of the WMS service. And again, if you've made any changes or if you're creating a new layer, make sure to hit the Save button before leaving this page. Otherwise, all of your changes will be lost. So let's hit Cancel. And now go to the Layer Groups area, where, as you might expect, as you've been seeing, the layer group provides an option for either creating a new layer group or viewing the existing groups and either updating, modifying, or deleting those. So in this case, let's choose to add a new layer group. And I can then say, I want to make this Carl Test. And I can then add layers. So I can click on Add Layers and choose the layers that I would like to add to this. So I'll add the world layer to this. And I'll add another layer, this GBoundaries layer. And I can generate the bounds for this now that I have added some layers. And you can see it's calculated that, or attempted to calculate it in this case, from the layers that I've added to the system. So I've hit Generate Bounds again, and it generated it correctly this time based upon the world layer that I've added. And then I can just hit the Save button to save that layer group that I've created. I can click on that layer group to see the options for it, and then also provide the ability to modify that if I would like. If we go down to the Styles list, we can see all of the styles that have been defined within the current instance of GeoServer, some of which are somewhat general purpose, others of which are very specific to particular layers or data stores. And just like the other configuration options, we can click on the name of a particular style in this case to view the settings for that particular style. Where GeoServer uses the Open Geospatial Consortium SLD, or Styled Layer Descriptor model, where essentially you can generate an XML file that defines a style. And you can view the current style definition here in the editing window or the view window within the style editor. Depending on your browser, you may or may not have a clear display of the style as it's being shown. So in this case, I'm using Chrome, and you can see that the style as it's displayed here is actually not particularly well formatted or clear. So I would, if I wanted to edit this style, want to copy the content and open it up in another text editor where I can modify that style and then possibly then paste it back in to first validate and then submit to the system. If you've created a file on your local system and you want to upload that style to GeoServer, you can choose the Choose File option, where if you click on that, it will bring a dialog box up where you can then select the particular file that you would like to upload. It will load it into the page, and then you can validate it and submit that style. And we will be working more with styles next week. In this case, we will hit cancel, so we make no changes to the system. As we move down to the users area, you can see the list of the current users in the system and the roles to which they have been assigned. And to add new users, you just click on the Add User button. Otherwise, you can click on the username to see the particular settings associated with that user, where you can create new roles, and once those roles are created, you can assign them to a particular user. This is not something that you will be doing in our instance of GeoServer for the class, but if you did stand up your own server, this is an area where you would need to do some work in defining users and user roles. Then, as I mentioned earlier, you also have options for updating data security, service security, and catalog security within the interface. Other areas of interest within the GeoServer system include their demo area, where you can actually see sample requests for a number of capabilities for GeoServer. So if we click on this demo requests link, you can actually see what some requests look like and consist of, and in some cases, what the outputs look like. And this is also someplace where you could provide your own demo request and submit the request to the server as a means of testing. But for example, we could do a WMS get capabilities request. It then generates the request here, and if I scroll down, I can submit that request. And that actually resulted, in this case, in a downloaded capabilities request that I can open up in another system to view. So I'm opening it up in a text editor right now. So here I've opened up the get capabilities request that I submitted as a test request or as a demo request to the system. And you can see, for example, that the contact information that I provided earlier is included here in the contact information for the get capabilities system. We can see the various formats that are supported for the get map request. We can see here the list of SRS values that I had defined as a part of the configuration, the limited list of SRSs that I've defined as a part of the configuration of the web map service. And then all of the layers that have been added to the GeoServer to date. Keeping in mind that essentially every layer that is added to the server is advertised as a part of the get capabilities request for the entire server and service. So as we add layers to the system, the response to the get capabilities request will continue to grow with all of the layers from all of the students in the class. Also within the demo area, is the list of SRS values, spatial reference systems, that are known to GeoServer, meaning that they are actually built into GeoServer as SRSs that can be used for publishing data or for doing coordinate transformations. So if we click on the SRS link, we can see that there are 4,636 spatial reference systems that are essentially baked into GeoServer. And so if you're wanting to look for a particular spatial reference system to see whether or not it's supported, or if you're wanting to see what the EPSG code is for a particular spatial reference system, you can use the search tool. So if we wanted to, for example, do a search for all state plane spatial reference systems, we can just search for state plane and see that we are looking at a list of the first 25 spatial reference systems in GeoServer out of a total of 40 that have the words state and plane somewhere in their name. And then if we wanted to actually look at more information about that particular spatial reference system, we can click on it and see what the name, scope, some comments, and then the well-known text representation of that spatial reference system is. That well-known text should look somewhat familiar to you, as that is a format that you have already seen as you are looking at the output of the OGR info or Google info commands that you have been working with in exploring data sets that you've acquired and downloaded to the system. But you can see that there is a lot of useful information about these various spatial reference systems built into GeoServer, in addition to just the basic information that in terms of the EPSG code itself. This can be a very handy tool for being able to identify whether or not particular EPSG codes are supported, and then getting more detailed information about those. Finally, we can go to the layer preview area, where we can see all of the layers that have been added to GeoServer, and then have a number of options for being able to preview those layers as an initial test to make sure that we're actually reading the data appropriately and that they are showing up the way we expect them to. So there are two ways to view the previews within the layer preview area of GeoServer. The first is to use one of the common formats that are available within the listing here. So we can choose, for example, to view this as an open layers map. So since this was actually a group that I created that included both the imagery and the boundaries, we can see here an interactive preview within open layers of the data from both of those layers. You can also go to the all formats list and view the other available formats that are available for a particular layer, where your mileage may vary given the characteristics of a particular layer and a given format. But generally, you can test the formats that you're interested in from this all formats list. So for example, if I wanted to request a JPEG for that layer group that I created, I can choose it from the menu here, and it will then open up the resulting image that is returned, in this case based on the web map service that is publishing that combined group layer. And you can see that in the URL up above, which by now you should recognize as a standard OGC WMS get map type request. So with that, this week's demonstration and discussion of the GeoServer interface and how it fits into the broader services-oriented architecture that we have been discussing all semester is complete. Next week, we will continue with the discussion of layer styling within GeoServer. And in the meantime, I encourage you to experiment with GeoServer both through the lab and just on your own.